All right, guys, welcome to Spiral Review number 4 for my 8th grade students. Today we are starting off with Transformation Station. I even have a little guy here, a little train engineer saying happy travels because we're going to take some of these shapes and we're going to make them go all over this coordinate grid. So it's so big I can't even fit it on the camera for just one shot. So what we're going to do is I'm going to model going through it once with all of my shape, and then you're going to have to do it with yours. Now you have to do both of these. You have to follow along with me and mark the same things. And that will help you prepare to do it independently. So for our pre-image, we're doing triangle ABC. That is this one. So if we go over 1, 2, 3, 4, 5, 6, 7 and down 3, just double checking, over 7, down 3, that's our A. Our B is going to be over 7, down 5, negative 5. And our C is going to be over 6, down 5. Okay. And I'm going to move through this pretty quickly. Oh, I'm so sorry if you could not see that very well. So I just kept going back and forth and the camera is so fuzzy it can't keep up with me. All right, number 2, reflect across the x-axis. So our x-axis goes this way. We're going to reflect across it just like a mirror. There's a trick to doing that with your coordinates, but you could also think of it as if this little A right here is a man standing, or a lady, or whomever, a dog, I don't know, standing 3 steps away from the X mirror, their reflection is going to be 3 steps the opposite direction. So we are not changing the X right, the X Y movement, we're changing the up down movement. So we just flip the sign of our Y. So that becomes 7, positive 3. And this B goes over 3, but they're 5 steps down from the mirror. So we're going to go 5 steps up from the mirror. There's B. And I'm not going to put A prime, B prime, C prime, because we are going to do lots of different motions, so transformations. So it's hard to keep track of. So we go down 5, we go up 5. So there's C. So if I write my new, or color my new triangle in, it will look like this. Okay. And my coordinates, like I said, they were 7, 3, 7, 5, and 6, 5. Again, all we did was we just changed the sign of our Y from that one to this one because we were changing how far up and down things are moving. Now I'm going to rotate 180 degrees counterclockwise, which means all I have to do are switch my signs. So when I had you do your rotation on the other one, I also picked a 180 degree one. I didn't pick a 90 or 270 because I didn't want you to have to like flip things around and then change signs. So just remember, you're just changing the signs. So where it was 7, 3, now it is negative 7, negative 3. 7, 5 is negative 7, negative 5, and 6, 5 is negative 6, negative 5. So just changed all the signs and they happen to all be positive, and now they're all negative. So negative 7, 3, negative 3, negative 7, negative 5, negative 6, negative 5. Okay, so again, A, B, C. Okay, if you want to put on here that this was number 2, and over here we've got number 3. Okay, that can be a clue to you as well. So we're sliding back over here. Sorry, now we're translating. We're just sliding. The X, Y, the X movement is left, right, and then the Y movement is up and down. So we're going to the right 3, and then we're going to go up 1. Each point is going to go to the right 3 and up 1. So let's start with A. Goes to the right 3, 1, 2, 3, up 1. B goes 1, 2, 3, up 1. C goes 1, 2, 3, up 1. And it makes sense. It looks like it has slid. So pardon me for possibly going off screen there. That is our 4th triangle. A, B, and C. Oh, I forgot to give my coordinates. So negative 4, negative 2. Because I went, if I look at it now, I'm negative 4, negative 2. B is negative 4, negative 4. And C is negative 3, negative 4. So just take it one step at a time. Take your time. You don't have to rush. The last thing we're going to do is dilate by a scale factor of 1/2. So SF I just ran out of room. Scale factor right there. And 1/2 just means we're multiplying all of these numbers by 1/2. So half of -4 is -2. Half of -2 is -1. -2, -2. Half of -3 is -1.5. So I'll put -1.5. You're not going to have to worry about that when you dilate. -4, half of that is -2, because a scale factor is always multiplication. But when you see something like multiplied by 1/2 or 1/3 or 1/5, we're actually dividing by 2 or by 3 or by 5. Okay, so now I'm going to take those points that I use the scale factor on. Again, I just multiplied literally each of those numbers by 1/2 or divided them by 2 to get this new set of coordinates. So I'm going to go over here and put this down. -2, -1 is my A. -2, -2 is my B. -1.5. So I'm going past the 1, almost to the 2. So that's -1/2 in this area. And then I'm going to go down 2. There's my C. So it's a tiny little guy because we had a reduction. We squeezed it, okay? Now that was my 5th and final triangle that I'm doing, okay? And you can see the movement on here. I designed this question so that when you do your triangles, none of my triangles are going to overlap and touch each other, since you've got a bunch of mixed up letters, or excuse me, mixed up shapes. So just know that if you see that 2 triangles are touching each other, then you may have to go back and check to see if you made any mistakes, okay? So just do that at the bottom, follow it one step at a time. You're going to reflect across the y-axis. That means, guys, you're going to go this way, so your x is going to change, not your y. Then you're rotating 180 degrees, changing your signs. Then you're translating x -3, y -4. X is going to be left-right movement, so you're going to the left, and then y is going to tell you to go down since it's negative. And then we're going to multiply all those numbers from step 9 to step 10, or to number 10, I should say, by a scale factor of 2. So you multiply, not divide, by 2. All right. Happy travels. All right. So on the back, I tried to lighten it up a little bit because I know that was a little bit heavier with the transformations. So I made a number line. You need to understand that we always have nicknames for numbers, and we can do them different ways. We can write them different ways. So like the square root of -81, or excuse me, the negative square root of 81, that makes a difference. This is 9. And so if I take the negative of that, it's going to be right here. So you can just draw like a line with an arrow to that spot. -55, that is going to be between what 2 numbers? You don't need a calculator for this. You know that the perfect square of 49 and 64, because 7 times 7 is 49, and 8 times 8 is 64. So 49, 64, this is an example, okay? That's the square root of 7, that's the square root of 8. So it's going to be somewhere between the 7 and 8, but not just that, it's going to be somewhere between this it's a negative there. Ooh, I can't talk right now. Okay, it's a negative. So if I were to take it between these two guys, it's going to be between -7 and -8. So it's going to be somewhere in here, and you can just draw that arrow right there. Okay, there are a couple that have pi on them as well. Here's another negative. We know that pi is 3.14. So negative pi is -3.14 approximately, right? We have to stop and round it at some point. So don't get confused and go to the right here. -3.14 is going to go past. It's going to go, we've got -1, -2, -3, and then a little bit beyond. So it's going to go right about there. Okay, and you can draw that arrow. Okay, you also have one that's 2 pi, one that's pi. So you should be able to do those. Those are nice and positive, which your brain is used to doing. Okay, I also gave you a positive square root of 55 over here. So the negatives and the positives, just be aware of those, because your brain has to sort of switch directions when that's the case. Okay, on the next section where we're talking about functions, functions here, which table of values can be defined by the function y equals 4x minus 2, which means if I plug in certain x's, and I multiply by 4 and subtract 2, like my function is telling me to do, what's the output? What's my result? Is it what is matching up with that x on my table? So if I plug in -10, 4 times -10 is -40, minus 2 is -42. That means that this number should be -42, and it's not. So this cannot be matching with that function. So I know without doing any more work that A is not going to be an answer. So like on the next one, go through and make sure, is 4 times -4 minus 2 going to be -18? If it is, then go through the other numbers. Is 4 times -2 minus 2 -10? Is 4 times 0 minus 2 -2? And go through on each of these and see which ones are going to match this function right here. Last but not least, oh yeah, also the question today, one of the questions is, functions are life. What you put into something affects what you get. What is one function you can do this week to help yourself or someone else? We talked about this in my classes recently, where what are you doing at home to make sure you're working hard on your stuff? You can't wait to be motivated to want to do math. No offense to all the math teachers out there, but that's probably not going to happen to many of you. So you have to take that first step, that first action to motivate you to get to work. And once you get that ball rolling, you put one foot in front of the other, you're going to be a lot more successful. So that's a good life hack for you there. So think about, what is one thing you can do to set yourself up for success? Okay. Last but not least, exponents. We've been working with exponents. You need to match the rule basically with how we're simplifying. So watch out, we do have an extra answer. We've got 5 questions and 6 answer options. So think about what you would do to simplify 5 to the 12th over 5 to the 10th. If you literally pictured 5 times 5 times 5 times 5, 12 times in a numerator and 10 times in a denominator, remember we've canceled those out. And so that's why our rule is we could just subtract them. That's our little shortcut. So it would be 5 to the 2nd power, which is 5 times 5. It would be 25. But I didn't even take it that far. I just wanted you to see how the rules played out. So that one would be B. All right. So that one's good. We don't need to use that one anymore. So think about, what do we do when we take groups of groups? This is a lot. And then we've got 5 to the 12th times 5 to the 10th. 5 to the 10th over 5 to the 12th. So just a little bit different than the one earlier. And then last but not least, 5 to the 0 power. So go ahead and do those. Make sure that you guys are checking your work, especially on the transformations when you're doing your travels. And let me know if you guys have questions in class. See you guys later.